Let's recap the interview question. You are given a fair coin. On average, how many flips will you need to get two of the same flip in a row? Either two heads in a row or two tails in a row. So let's calculate the probability of getting two consecutive flips on the nth toss. Either two heads or two tails. So we make things simple. Let's say we put n equals to 2. So on two tosses, what is the probability of you getting either two heads or two tails? So out of two tosses, there's only four outcomes. Your first toss is head, second toss is head, so it's head head. First toss is a tail, second toss is a tail, so you get tail tail. Or first toss you get a tail, second toss you got a head, you get a tail head, and the last toss you might get a head and then a tail. So there's 2 out of 4 times that you can get either 2 head or 2 tail. So the answer is half. So we need to generalize this to the nth toss. So let's calculate the probability of 2 consecutive flips, 2 heads or 2 tails on the nth toss. Before we think about the 2 consecutive flips happening, what will be the event before that? So before that, it will be an alternating series. So it will be head tail, head tail, head tail, or tail head, tail head, tail head, until you get the same flip as the previous one, either a head or a tail. So we will generalize the sequence as 1 to n minus 1, because at the end toss you get the consecutive flip. So n minus 1 will be the one before you getting the consecutive flip. So we want to calculate the probability of this series 1 to n minus 1. So what is the probability of that series 1 to n minus 1 before the consecutive flip happens? To recap, the series is tail, head, tail, head, tail, head, tail before getting another tail, or either head, tail, head, tail, head, tail, head before another head that happens. So for n minus 1 tosses is 2 over 2 to the power of n minus 1, because in one series either tail head tail or head tail head, the sequence is 1 over 2 to the power of n minus 1. This is because it is a fair coin, so the chance of flipping an alternate tail head or head tail, the chance of that happening is 0.5. So every time we multiply half times half times half all the way to the n minus 1 times. So we will result in, if you generalize this series, it will be 1 over 2 to the power of n minus 1. And because there are two series, because you can throw tail first or either head first, then because there are two alternating series, so you multiply 1 over 2 to the power of n minus 1 by 2. So you get 2 over 2 to the power of n minus 1. So we get this generalized series 1 over to the power of 2 to the power of n minus 1. So we know that the nth toss needs to be bigger than 2, because at least there must be 2 toss. We know that the nth toss where it matches to the previous toss is half, because it could happen either heads or tails. So we multiply the series that we generalize by half, and we get 1 over to the power of n minus 1. The formula for expected value is the number of occurrence multiplied by the probability. So to sub in our starting I equals to 2 and a probability of half, and we get this. To calculate the infinity sum, we multiply by the common ratio, which is half, to s. So we get this series. Thereafter, we minus half s from s, and we get this series. And we know that from this portion onwards, it generalizes to this, adding up to infinity, it tends to 1. Simplify the equation to s minus half s equals to half plus 1. And moving everything to the right side, we get s equals to 3. That's why the answer is 3.